The car is wrecked like this. The Audi is definitely totaled. Right? I called a tow truck. 5 minutes out. Follow my lead. Stop filming, let's go. Go, 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 move, move, move. Imagine you've stopped at an intersection. And suddenly the rear takes a hit. Then the front. Then a slam to the side. Would you walk away without a scratch? Not even a dirty shirt? This time, top safety is hitting the Audi E7X with a 3-impact test. First hit, a sedan. 80 km per hour. 70% offset rear strike. At the moment of impact, the E7X is left in park to amplify the force even further. Second hit, an SUV. 65 km per hour. Random offset head-on. Third hit, a 4-ton truck. 50 km per hour, random offset side impact. No swapping out the struck vehicle. No clearing the bullet car. Obviously, this is more brutal, more random, and more extreme than any standard test. And of course, it's also much closer to the extreme worst case crashes on real roads. Impact 1, starting now. You can see the E7X was shoved back about 1 car length. The bullet car's trunk lid got popped open. But the upper half of the E7X's trunk doesn't seem to have taken much impact. Most of the force concentrated in the lower half. Next, the SUV comes in from the front. Because of the random collision angle, plus the E7X being noticeably heavier, the reaction force from the bullet car gets split into a rotational component, causing the whole body to spin 90 degrees. And the E7X's damage situation doesn't look great either. The final impact. The 4-ton truck's rear wheels came off the ground. The E7X is shoved back several meters again. And on top of that, since neither bullet car 1 nor 2 was cleared beforehand, the third collision meant the E7X was getting squeezed from both sides at once, causing deformation on both sides. There is deformation, but the doors can still open fully. The door handles popped out, and all 7 airbags deployed successfully. From an initial assessment, the longitudinal rail structure is mostly undamaged. We can see the shotgun area has some deformation. Minor deformation like that won't affect the cabin. The rocker panel on the side still looks completely straight visually. And that was a 4-ton truck hitting it directly. That rocker panel earned its keep. The reinforcement beams inside the front and rear doors completely held up against that impact, deforming out beyond the exterior shell. The rear end speed was just too high. 80 km per hour. The rear impact beam is completely deformed. Alright. Up to this point it's been exciting but maybe light on technical depth. Well, now comes the main event. We took this demolished E7X back to the workshop. Stripped it completely to expose the bare body in white. We're going to show you the underlying logic behind passive safety. See if it changes how you think. After a crash you actually see more. Like this really interesting illuminated trim panel. The actual light source is here. And also here. What you see directly below is a reflector. Laminated safety glass. And that stringy stuff you're seeing is the interlayer. First time seeing it this clearly, right? Audi tail lights. Anyone want one? Let me know in the comments. Okay, let's tear it apart. The worst hit front left turn signal is out now. The sound deadening is really thorough. Even the 2 cable pull rods have foam tubing around them. Now let's look at the inside of the door panel. It does have some deformation, but nothing intruded into the occupant's leg area at all. Why? 2 reinforcement beams did the job. They held that truck off. We also pulled out the full door lock actuator assembly. Also a power-operated flush door handle. The E7X's pop-out mechanism puts out 200 newtons. Winter ice braking and minor crash deformation. Both still let it deploy normally. And in this crash, it did indeed respond correctly. Now we're looking at the body in white. There's still more to remove. The front and rear impact beams, and the front and rear subframes. But those are all structural components within the passive safety system. So we're leaving them on. That actually lets us more clearly see how the force was distributed in this crash. The front impact wasn't an offset head-on. It should be called an offset angled strike. The impact force on the passenger side A-pillar is actually reduced somewhat. But the chassis structure in front of the firewall takes more damage. The right side primary and secondary crash boxes completely collapsed along their designed crush holes. So notice, even though the hit was on this side, the crash box on this other side has also displaced. From a structural perspective, it's now formed a kind of cube shape, like a cage structure. So what we see is, even though the impact was on this side, the right side longitudinal rail has no particularly obvious deformation. Instead, the left side rail was pushed outward. Let's do a quick measurement. The diagonal distance from root to tip of each rail differs by nearly 3 centimeters. And because of the multiple cross members between the rails, the right shotgun bar and strut towers, lateral deformation tendency is greatly reduced. Instead, the whole structure gets pushed upward longitudinally. When removing the right strut tower and its connection to the firewall, we confirmed this exact deformation pattern. The E7X also hides a wedge block at the end of the impact beam. In a small angle offset collision, it effectively compresses into the crash box zone, then steers the front end away in the opposite direction. And you can see on this side, the wedge block clearly pressed into the crash box. It definitely did its job. The subframe on a pure electric vehicle is on a completely different level from the gas car era. It's not even comparable, because it doesn't need to leave room for an engine to drop down into. So the design is much freer. You can just add cross members to protect the battery. They added a lowered cross member right here. That makes it 1, 2, 3. 3 cross members total. And because it wasn't wide enough laterally, they added 2 small tabs here to prevent the subframe from shifting back and damaging the battery pack in a frontal crash. The underbody shield here is clearly composite material, light and impact resistant at the same time. This is just the visible outer protection around the battery pack. There's also invisible protection, like a hot-formed steel and aluminum composite structure in the sill. It needs to survive the extreme impact, while still absorbing some energy. Meanwhile, on both sides of the battery pack, there's 40 millimeters of designed crush space to handle worst-case contact. The side impact this time was like stepping on a milk carton, flattening a rectangular structure. That caused the whole thing to shift rearward, pinching the door against the door frame. On the body in white materials, the E7X uses large amounts of hot stamped steel and advanced high-strength steel. The lower firewall, A and B pillars, and 3 floor cross members together form the strongest possible cage structure. Looking at the post-crash body in white again, you'll find the data and the real-world results match perfectly. There's something special about this A-pillar. There's a technology inside called CBS. Let's take a look with an endoscope. CBS is a composite body reinforcement technology. It's inserted into the A-pillar before the electrocoating process. Then when the car goes through the paint baking stage, an internal adhesive expands, fills the cavity, and bonds in place. With CBS in place, the A-pillar's bending resistance is significantly improved. Of course, CBS also helps with weight reduction. Compared to a metal reinforcement approach, the E7X's A-pillar saves 2.4 kilograms. So this technology was first used on weight-sensitive sports car brands, like Porsche. Looking at the floor in this state, you can thank the front and rear ends for deforming enough on their own and saving this floor with zero warping, wrinkling, or deformation anywhere. The entire cabin is just solid. Which brings us to that most fundamental question. Is a stiffer car always a safer car? Of course not. A good body in white needs both hard points and soft points, because it's the soft points deforming and absorbing energy that keep you within a survivable deceleration threshold. If the entire car were all hard points, then you'd become the only soft point. This rear end looked absolutely devastating. The car behind had its rail spear directly into the center of this car. Went straight in. And it did compress into this section, causing the OBC to lift slightly. But the OBC itself wasn't actually crushed. To summarize, I think top safety underestimated the E7X. The damage so far is superficial. The floor buckling I wanted to show, the force punching through the body type of propagation, didn't happen. But I have to say, this has been more meaningful than any full teardown we've done before. By a long shot. It's given everyone a direct, highly concrete look at how passive safety actually works in a modern car. Also, about the E7X, I pulled out 2 completely unexpected findings worth sharing. First, the sound-deadening material. Every single cavity must be filled. Below the A-pillar. Behind the fender. Inside the rear wheel arch. Pull it out and it's still packed full. And they didn't use just one type. There's also a different acoustic layer bonded to the body in white. The left and right fenders. Each have a contoured acoustic pad cut and fitted to match the body shape. Even the front and rear door sills get no pass either. Same acoustic treatment applied. And all the HVAC ducts in this car are completely wrapped in thermal foam insulation. Why mention this? Cars we've taken apart before also had it. But it was patchy and inconsistent. A luxury brand still has its own standards. Perfectly fitted. The acoustic layer on the back of the dashboard is a sandwich structure. Outer layer is PET. Inner core is a PP acoustic pad. Whether it's acoustic performance, eco-friendliness, or weight, it's all top tier. And the cost is top tier too, obviously. As for the total amount used across the car, just take a look. The E7X uses at least 6 types of acoustic material. Beyond the more common foam and felt, there's also PET, polyurethane, and high rebound foam. Plus combinations of the above. Double and triple layers used heavily. Every nook and cranny packed full. Single layer is the minimum, double for large cavities. Triple layers aren't unheard of either. But the most jaw-dropping part is how every piece of acoustic material is cut to perfectly match the shape and cutouts of the corresponding component. The cutting and fitting costs alone are just insane. This is what separates a luxury brand. Shown in very concrete terms. Details, people. This hanging on the inside of the firewall is the evaporator core assembly. Setting aside the acoustic material here, anywhere there's an airway, there's a layer of foam added as a support seal. That foam feels about twice as thick as anything we've seen before. And foam in different positions has different properties. This one springs back fast, while this one must have rubber in it, because it springs back very slowly. Details, folks. The airflow flap inside has a rubber gasket all the way around. And every soft and flexible component in there is machine cut. Perfectly fitted. No sign of any hand cutting anywhere. The other finding worth sharing is the chassis spec. Give it a name, and you'd call it an all-aluminum chassis. Front and rear suspension. Except for one part that needs torsional flexibility, the anti-roll bar, which can't be aluminum. Everything else is aluminum. According to official figures, this all-aluminum chassis saves over 52 kilograms in structural weight reduction. And the rest of the components are all flagship grade too. Continental air springs, ZF-CDC dampers, Brembo brakes, and this EV is actually fitted with high rolling resistance tires. Clearly this is a setup that prioritizes driving feel above all else. This E7X is the most expensive car we've ever torn down. Not in terms of sticker price, but because we got an enormous amount of theoretical knowledge, cross-validated against real-world evidence, making this wrecked shell's value far exceed that of a brand new car. For the first time, we also saw directly that a luxury brand has so many materials and technologies that never show up on the spec sheet. Holding the line responsibly will always be noticed by customers in the end. Turns out Audi had one more thing it wasn't telling us. The day after the challenge, another E7X was hit by a concrete pipe. 5.5 tons dropping down onto the car. The chassis nearly bottomed out. The result? The 3 advanced high-strength steel crossmembers in the roof held the concrete pipe firm, giving the A, B, and C pillars the cabin zero visible deformation. Once again proving the E7X cabin's exceptional protection.